Hello all, I am Shatabdi Acharya from Vedang Institute of Technology. In the previous videos, we were learning some important thing about carbon. We were knowing what carbon is, what kind of bonding carbon undergoes, what are the properties of carbon, what are the allotropic forms of carbon, right? So now we are all set, we are all ready to dive deeper into the topic of organic chemistry. So before going on deeper, let us know initially what is organic or what are organic compounds, right? So we only knew one member of the family, that is carbon. Carbon is the boss of the family, head of the family. All carbon compounds with hydrogen, okay, carbon compounds with hydrogen, we name them as hydrocarbons. Hydrocarbons. Basically, carbon along with hydrogen are named as hydrocarbons. Now, what are organic compounds? If carbon is linked to hydrogen, which is in most of the cases, carbon forms majority of its bond with hydrogen only. Apart from hydrogen, it can also form bond with other elements like oxygen, nitrogen, halides, okay, different group of compounds, like different class of elements. So, the basic definition of organic compounds are the hydrocarbons and their derivatives. Okay, hydrocarbons and their derivatives are called as organic compounds. Basically, all those class of compounds which are made up of purely carbon and hydrogen, hydrocarbons, or hydrocarbons and other elements like carbon, hydrogen and some other elements, those are called as derivative of hydrocarbons. For example, if I am saying a pure hydrocarbon, that is CH4, carbon has to satisfy 4 bonds and these 4 bonds are satisfied by all hydrogen atoms. This is a pure hydrocarbon. Now, if I remove one hydrogen and place a chlorine instead of that, I am getting a different class of organic compound. The name we will learn later, but for the time being, understand it is as haloalkane. Okay. So, carbon, it was initially it was having 4 bonds with hydrogen, hydrocarbons. Now what I did, the 4 bonds are intact, but I just changed an atom from that. I removed one hydrogen atom, added a chlorine atom instead. I got a new class of compound, and that class of compound is derived from the parent compound. So hydrocarbons are my parent carbons or parent compounds, and from hydrocarbons I will be deriving various classes of organic compounds or various different classes of organic compounds. They are called as the derivatives of hydrocarbons. So basically this entire group of compound is called as organic compound. Hydrocarbons and their derivatives are called as organic compounds. Now by default we know, as carbon is only having the tendency to form covalent bond, therefore all the organic compounds are covalent compounds, right? So the next important thing to note here is all organic compounds are covalent. Now, if they are covalent, they must be softer, they must be having lower melting and boiling point than ionic compound, right? So we can write that also. They have lower melting and boiling point. They have lower melting and boiling point, which is typical to all the covalent compounds. Now, where did these organic compounds come from? Like, where did the concept or the idea of organic compounds came into being? So, in the previous lecture, we have learned carbon exists in 2 basic forms, in a free state and a fused state or a combined state. So in a combined state, carbon is present inside our body as carbohydrates. For example, glucose, that is a carbohydrate. So we can basically say all living beings, the core skeleton structure is carbohydrate. Like all entire living beings are made up of carbohydrates. So initially what happened, we were in a thought ki like organic compounds cannot be synthesized artificially. They are only naturally available, and a natural force called as a vital force, known as a vital force, was responsible for the formation of organic compound. Therefore, we were initially believing upon this vital force theory, because lab synthesis or artificial synthesis of organic compound was not done till that time, right? But gradually, as time passed by, a person called Fuller discovered urea, and this is the first artificially synthesized organic compound to be discovered. Urea with the formula NH2 CONH2 was discovered, and the vital force theory was proved wrong. From then onwards, we discarded our vital force theory. We are no more believing upon that theory, and we are in a belief now, or we have synthesized a lot of n number of organic compounds in our laboratories. Okay, so this is how organic chemistry became a branch of study. Okay, now why carbon only? Why carbon is the only element which was of so much importance in the formation of organic compounds? Due to two reasons. First of all, you all are aware of catenation. What is catenation? The self-linking tendency. Basically, carbon atom can form a bond with its own brother, its own atom, and like that it can continue up to a long chain, because carbon atom is smaller in size, it has lesser or distance from the nucleus, or greater nuclear influence on its shared pair of electrons, as a result of which the long carbon skeleton formed is stronger. So now I have carbon skeleton before me. Now, this carbon is having other, basically carbon has a tendency to form 4 bonds. So this carbon, only 1 bond is satisfied for this, and for this also 1 bond, but the rest of the carbon 2 bonds are satisfied. Each carbon atom here is having 2 other tendencies or 2 other unpaired electrons to satisfy, to form bond with, and this first and the last carbon, they have 3 unpaired electrons to form bond with. Now this makes this skeleton very flexible. I can add any atom or any basically atom only. I can add any atom to this skeleton to get a class of organic compounds. That is the first reason. Like, it has the strong tendency to form long chain. It can link with its own atom by the property of catenation, as a result of which it can form long chain of compounds. Second thing is, carbon has tetravalency, a valency of 4. Okay, tetravalency of carbon. Carbon has a tendency to form 4 bonds, and these 4 bonds can be formed with 4 different atoms. And this valency is quite large as compared to other atoms to form bond with. As a result, it can give us large number of organic compounds. So basically, because of these two reasons, carbon shows a wide variety of organic compounds before us. Now, we will understand what are the types of organic compounds. what are the types of organic compounds. So what we have learned is, what are the definition of organic compounds? Pure hydrocarbons or their derivatives. So our first class of compound will be hydrocarbons. Made up of carbon and hydrogen only. Now we take an example of this as CH4. Okay. Next thing what I do, I will remove one hydrogen. Okay. I will remove the CH3 remains the same. One hydrogen I will remove. 4 hydrogens were there. I got rid of one hydrogen. I'm having 3 hydrogen with me. And the fourth valency, suppose, is satisfied with Cl. This is one case. In this, if one hydrogen is replaced by a chlorine atom or a halogen atom, we get a class of compound called as alkyl halides or haloalkanes. Common name haloalkanes. Okay. If I replace one hydrogen with a chlorine atom, I get another class of organic compounds named haloalkanes. Now the same thing, if I keep CH3 skeleton intact and replace it with OH. Okay, let me just color code it with OH. If I am replacing that hydrogen atom with the OH atom, I will get a class of compounds called as alcohols. Okay, I'll get a class of compounds called as alcohols. Now, if I keep the carbon skeleton again CH3 and replace it with the hydrogen, initially I replace it with CHO. I get a class of compound called as aldehyde. If again I replace that class of compound or that hydrogen with COOH, I get carboxylic acid. So these are some of the few out of the large number of class of organic compounds carbon can form. Each time what I did, I replaced one hydrogen with a different compound and I'm getting a totally different class of organic compounds, right? So basically I can say, okay, what difference do we observe here? This is called methane. Okay, it will have some different property. This, when one hydrogen atom is replaced by a chlorine atom, we get haloalkane. That haloalkane will have a different property than methane. Similarly, alcohol, aldehyde, carboxylic acid. Each will differ in their property because of that replacement of that one particular hydrogen atom. If I am replacing that hydrogen atom, I am getting a very wide class of organic compounds. They are having different physical and chemical properties. They are becoming altogether new compounds, right? And why is that difference coming? Because of the presence of these newer groups, right? The Cl, OH, CHO, COOH. So basically these groups determine the physical and chemical properties of the organic compounds. Basically these groups help in the functioning of the organic compounds. Therefore these classes are known as functional groups. These groups are called as functional groups because these groups define the properties of the organic compound. If I change one group with another, it's just a matter of few letters, right? If I change the letters, I get an altogether different class of organic compound with different physical and chemical properties. Therefore, these letters, the combination of letters which we call functional groups, are very important in organic chemistry. Okay, these basically determine the physical and chemical properties of the organic compounds at hand, whatever we are dealing with. Okay, by simply looking at this OH or CHO or COH, simply, you don't have to look at anything else apart from these groups. Simply looking at these groups, you can determine the property of that class of organic compounds. Suppose I'm having n number of C before it, that doesn't matter. Simply what matters is the presence of this group. Therefore, this group is very crucial and we name it as functional groups. Okay, so now it's time that we take up individually one group and study them in detail. Okay, so first of all, we'll take hydrocarbons. What are hydrocarbons? The combination of carbon and hydrogen or the class of organic compounds formed purely by carbon and hydrogen are called as hydrocarbons. So, the class of organic compounds formed by a combination of carbon and hydrogen are called as hydrocarbons, and our example which we have already seen is CH4 methane. Okay, for now we are quite familiar with methane, that's why I'm giving methane example in everything. Once we proceed into the chapter, we'll be dealing with newer organic compounds. Okay, so what are hydrocarbons? The class of organic compounds formed by the combination of carbon and hydrogen only. And this is the parent carbon compound or the parent organic compound for all other functional groups. Okay, this is the parent organic compound. From this class of compound, other compounds are derived. Okay, we learned in the definition of organic compounds, hydrocarbons and their derivatives. So this is that hydrocarbon, the parent compound, and from this various other functional groups are derived. Okay, so hydrocarbons, we got familiar with what is hydrocarbon. It is the parent compound, and now we'll see what are the types of hydrocarbons. We'll see okay, types of hydrocarbon. If you see broadly, we classify hydrocarbons into two categories. One is saturated hydrocarbon and unsaturated hydrocarbon. Saturated we have saturated hydrocarbon and unsaturated hydrocarbon. What are saturated hydrocarbons? Those hydrocarbons in which carbon only forms single bond. Okay, those hydrocarbons in which carbon forms only single bond with itself. Okay, so saturated hydrocarbons are those hydrocarbons in which carbon atom forms only single bonds, and carbon cannot form double bond with hydrogen, cannot form any bond other than one with hydrogen, because hydrogen is only in deficiency of one single electron. That's why one hydrogen atom will only form one bond. Therefore, it is safe to write those hydrocarbons in which carbon atom forms only single bond with itself. because it cannot form multiple bonds. It has no scope of forming multiple bonds with hydrogen. So those hydrocarbons in which carbon atom forms only single bond with itself are known as saturated hydrocarbons. Unsaturated hydrocarbons, those hydrocarbons where carbon has a tendency to form more than one bond Okay, those hydrocarbons where carbon has a tendency to form more than one bond with itself, they are called as unsaturated hydrocarbons. Now, carbon has 4 unpaired electrons, so it can form, obviously it can form a single bond, but beyond single bond it can form also double bond, triple bond and even 4 bonds? No. 4 bonds between a same atom are never possible. It leads to electron density and crowding around the atom. Then the electron clouds start repelling each other. So the stable arrangement is of a 3 bond. So max to max carbon can form 3 bonds with its own atom, right? So here in saturated hydrocarbons we are 1 bond down, right? Carbon atom forms 1 bond with another carbon atom. Now if it forms 2 bonds or 3 bonds with another carbon atom, they come under the class of unsaturated hydrocarbons. Now another important point to note here is, if carbon atom is forming single bond with itself, it can form double bond with itself, it can form triple bond with itself, right? If carbon atom is forming single bond, that class of saturated hydrocarbons are called as alkanes. ANE stands for single bond. Okay, this ANE stands for single bond, right? So if carbon atom forms one single bond with another carbon atom, they fall into the category of alkanes. Got it? Now if carbon forms double bond with another atom or carbon atom, they come under the category of alkenes. ENE stands for double bond. Okay? If carbon atom forms double bond with another carbon atom, they fall into the category of alkenes. Okay? If carbon atom forms triple bond, obviously they fall under the category of alkynes. These YNES represents triple bond. So, carbon atom forming single bond form under the category of alkane. Carbon atom forming double bond form under the category of alkenes, and carbon atom formed triple bond fall under the category of alkynes. Now, another important thing to note here is, if carbon atoms form single bond, that is by default a sigma bond, right? But if carbon atom forms 2 double bonds, then the first form bond will be sigma, the next one will be pi. If it forms triple bond, then first bond will be sigma, the other 2 bonds will be pi. And we know, if we compare sigma bonds and pi bonds, sigma bonds are stronger than pi bonds are weaker, so they are easy to break. And pi bonds, remember the balloon experiment, like the balloon demonstration I have shown you to make you understand sigma bond and pi bond. So pi bonds are basically present above and below the plane, right? So they are more exposed, they are weaker bonds, therefore pi bonds are prone to breakage. Okay, prone to breakage, therefore those having pi bonds, they are more reactive than the ones formed by only and only sigma bonds. Therefore, alkanes fall into the category of very unreactive compounds, and alkenes and alkynes are reactive as compared to alkanes. Okay, therefore alkanes are also known as olefins. alkenes are known as paraffins. Paraffins means little affinity. They have little affinity towards any particular reaction. Okay, therefore alkanes fall into the category of paraffins, which means little affinity. Alkenes form under the category of olefins, which means oil forming compounds. Oil forming compounds. Okay, alkenes fall into the category, or they are commonly known as olefins, which means they form oily compounds, oil forming compounds, therefore olefins. Alkynes as such do not have any particular name. Now, how we will determine, or what is the general formula of writing an alkane? What is the general formula for writing an alkene and that of alkyne? So, let us see the general formula of the following compounds. Okay. First, we'll take up alkane. Alkanes have a general formula of CnH2n plus 2. Okay, and the value of N varies or starts from 1, 2, 3, likewise. Okay, it goes on increasing. Now, similarly for alkenes, the general formula is CnH2n. Okay, similarly, the value of N varies like this. Okay, and for alkynes, the general formula is CnH2n minus 2. Then the value of N varies like this. Okay, these are the general formula. Now, considering these general formula, we'll try to write various alkenes, alkynes and alkanes. Now, if I put the value of N as 1 here, in all the cases, let me show you an example where I'm putting the value of N 1. So, if I'm putting the value of N 1 here, the alkane will be C1H2 into 1 plus 2. So, CH4, that is methane, right? Now, if I see alkenes, what I'll get? C1H2 into 1. So, CH2. Okay, but is there any bond or any compound possible with CH2? Because carbon is having other 2 bonds vacant. So, alkenes will have all these value of N except 1. Okay, so the number N will start from 2, 3 and onwards. It will never be 1 for alkenes and alkynes. In the case of alkyne also, the value is starting from 2, 3 and onwards. So here, if I put the value of N as 2, C2H2 into 2. So what I get? C2H4. How it will be formed? Carbon, carbon. First we are drawing the bare minimum, 1 bond we are giving to carbon. H4, equally distribute 2 to this, 2 to this carbon. Now for this carbon, how many bonds are satisfied? 1, 2, 3. It is still having 1 unpaired electron, and the same goes for this carbon also. So they will form 1 bond among themselves. This is the formation of a double bond. Hence they fall into the category of alkenes. Now if I see the case of alkynes, I'll put the value of C2H will be CnH2n minus 2. 2 into 2, 4, minus 2, 2. C2H2. So if I try to draw carbon-carbon, bare 1 minimum bond satisfied, 1 hydrogen over here, 1 hydrogen over here. Basically, we are following symmetry and we are equally distributing hydrogen to both the carbon atoms. Now, if I see this carbon, only 2 valencies are satisfied. It is left with 2 more. Same goes for this. So, they satisfy this by bonding among themselves, forming a triple bond, which makes them fall into the category of alkynes. Okay. Now, if we closely observe, Let me take only the example of alkanes over here. If I am saying N equals to 1, I am getting CH4. If I am saying N equals to 2, I will be getting C2H6. Okay, C2H6. When the value of N is 3, the compound will be C3H8. When the value of N is 4, I am getting C4H10. So if I compare this, all these two groups, they have a difference of a CH2 group. These two groups have a difference of CH2 group. These two groups have a difference of CH2 group. Therefore, and this trend continues throughout the series of alkanes. Okay, you continue increasing the value of N. All the alkanes under this will differ by a CH2 group. Okay, if you want, you can try and see. So, basically, all the class of alkanes differ from one another by a CH2 group. Okay, so these groups or these class of compounds which differ from another by a CH2 group are said to fall under the category or under the same homologous series. Homologous series. Homologous series basically is a group of compounds where each compound or the preceding compound differs from the succeeding compound by a CH2 group. Those category fall, those class of compounds fall under homologous series. So alkane belong to a same homologous series. Alkene is a homologous series. Alkyne is another homologous series. Okay. If you want, you can try and see in your notebook. Okay. So the next thing is, if I am saying this is CH4. Okay. This forms into this falls under the group alkane, right? This was an alkane. Now, if I remove one hydrogen, minus H, one hydrogen I will take up from this CH4. It will become CH3, and yet it has a vacant site for bonding. So, this is called as a alkyl group. This is called as a alkyl group. So, I can write alkane minus hydrogen gives you alkyl group. Okay. So, in this video, we came to know about what are alkanes, what are alkenes, what are alkynes, how they fall under the category of saturated and unsaturated hydrocarbons, what are alkyl groups, and from these alkyl groups only we will be deriving other organic compounds, right? So, how alkyl group is formed is also very important to us. Now, we will continue our lecture further in the next video, where we will see how to name this compound. What are the nomenclature rules for organic compounds? So, that's all for this video. Thank you very much.